Now let us begin by reminding ourselves some facts about rhombus. The length of all four sides are the same. So AB is the same as CD and AC and BD. Now the question is, how do we show that the quadrilateral AEFGH is a rectangle? By using a vector. What I'm going to do is we're going to find the vector EH and EF and show that they are perpendicular, and by doing so this would be sufficient to show that, or prove that, EFGH is indeed a rectangle. And because if this is perpendicular, you have no choice but this to be perpendicular to, and so. Right, so I'm going to start by letting the vector AB be equivalent to, well, say let's call it A, and I'm going to call the vector AC as B. It's so easy for me to refer to them. And now, so how do I find EH? EH as a vector is of course EB to BH, and EB is actually half of AB, and we know that BD and AC they are parallel, so BH is in fact half of BD, and in other words, this is actually half of A plus half of B, since BD is in fact parallel and same as the vector AC. Right? Isn't it cool? And so now I'm gonna try to get EF. EF is well, it's just EA and AF. If you think about it, it's actually half, or rather negative half A, because we go in the opposite direction, and this is going to be AF going to be half of AC or half of B, right? And now what I'm going to do is we're going to use the dot product to dot these two vectors. And before we proceed, I would like to look at this, understand that AB is equal to the magnitude of the vector A is the same as a CD, right? Because the same length, and however this is actually same as the vector B, which represents AC. So all these are the same, and AC and BD. So all these all four sides are same length, and means although probably A, B are not the same vectors, but the magnitude of A is definitely the same as magnitude of B. This is an important fact here. And so we're going to dot this. So let's start with EH dot EF, and this is in fact half A plus half B dot I'm going to re-express this differently. So I'm going to write as half B plus negative half A. It doesn't really matter if you don't do that, just find that. So this becomes half A dot half B. You recall that there's this property that you may use. So it's as if you are expanding it normally, but be careful, you have to use the dot between them, and you have now half A dot negative half of A here, And finally, I have half of b dot negative half of a. And so this is the same as 1 over 4 a dot b. And I'm going to deal with this one here. This is going to negative plus negative. Okay, so I'm done with this one. Okay, I'm going to do with this one, deal with this one. It's going to be 1 over 4 b dot a. Next we're going to deal with this one. It's going to be 1 over 4 b dot b. I'm going to do it step by step because I do not want to rush this. It's 1 minus 1 over 4 a dot a, right? And so we have 1 over 4 a dot b, and we do know two things. One is that a dot b is, this is commutative, is equivalent to b dot a. The other one is that another property is that if we dot vector by itself, is equivalent to this. And so this is minus. So although this is b dot a, is in fact a dot b, and this is essentially 1 over 4 b square magnitude b, and this is minus 1 over 4 the magnitude of a being squared. Now of course these two are essentially, well, the negative of the other one, so this is 0, and this you have 1 over 4 b square. But we have established that the magnitude of vector a is the same as magnitude of vector b, and so we can then replace magnitude of a with magnitude of b square. Of course the outcome is 0, and then you can then conclude that EH is therefore perpendicular to EF, which implies that EFGH is a rectangle. Isn't it wonderful? This simple idea using vectors, we're able to show that this inscribed quadrilateral is a rectangle. I hope you try the other questions, and all the best.